The instructions that we've looked at so far perform simple single operations. The 8086 has further instructions that can perform a number of operations in a single instruction. These are the type of instructions that we want to look at in this lecture. Looping instructions allow a block of code to be executed a number of times. The number of times that the block is to be executed is stored in register CX. Each time the block is executed, register CX is automatically decremented until it becomes 0. The 8086 looping instructions are loop, loop if 0, and loop if not 0. The loop instruction decrements the counter register and then branches to the start of the block if the counter register is not 0. The loop if 0 instruction decrements the counter register and then branches to the start of the block if the counter register is not 0 and the Z flag is set. Loop if not 0 decrements the counter register and then branches to the start of the program if the counter register is not 0 and the Z flag is not set. Let's illustrate using the copy-paste example. The block of code inside the highlighted boundary is executed a number of times. The two instructions inside the new boundary are the ones that enable the block of code inside the first boundary to be executed a number of times. We notice that the two instructions perform an operation that is equivalent to the operation performed by a loop instruction. Therefore, we can replace these two instructions using the loop instruction. In this case, the loop instruction decrements the counter register and then causes branching to the label move next if the counter register is not 0. By the time the counter register is decremented to 0, all the 1000 H items in the source block would have been copied to the destination block. A string instruction performs an operation on operands pointed to by the index registers SI and DI, and then increment or decrement the index registers so that they point to the next items in memory. Incrementing or decrementing the index registers readies the microprocessor to operate on the next items in memory. This is the reason why we call them string instructions. Let's look at the 8086 string instructions. The move string instruction copies an item from the memory location pointed to by SI to the memory location pointed to by DI. After that, it adjusts SI and DI. The load string instruction loads the item in memory location pointed to by SI into the accumulator. After that, it adjusts SI. The store string instruction stores the contents of the accumulator into the memory location pointed to by DI. After that, it adjusts DI. The compare string instruction compares the item in memory location pointed to by DI to the item in memory location pointed to by SI. After that, it adjusts DI and SI. The scan string instruction compares the contents of the accumulator to the contents of the memory location pointed to by SI. After that, it adjusts SI. The direction flag DI tells whether SI and DI post decrement or post increment after an operation. In other words, it tells whether the adjustment is an increment or a decrement. The clear direction flag and the set direction flag instructions are used to clear and set the direction flag respectively. Let's illustrate the use of string instructions using the copy-paste program. The block of code inside the highlighted boundary copies a single item from one memory location to another memory location and then increment the source and destination pointers. We can replace this code section using a single move string instruction. The move string instruction copies one item from the source block to the destination block and then increment the source and destination pointers. The loop instruction will then decrement the counter, and if the counter is not 0, branch to execute the move string instruction. This will continue until the counter goes to 0, a point at which all the items in the source block will have been copied to the destination block. The repeat prefixes allow a string instruction to be executed for a number of times. The number of times that the instruction is to be executed is stored in register CX. After each execution of the instruction, register CX is decremented until it gets to 0. The 8086 repeat prefixes are repeat, repeat if 0, and repeat if not 0. The repeat prefix causes the instruction to be repeated as long as the counter register is not 0. The repeat if 0 prefix causes the instruction to be repeated as long as the counter register is not 0 and the Z flag is set. The repeat if not 0 prefix causes the instruction to be repeated as long as the counter register is not 0 and the 0 flag is set. Let's apply the repeat prefix to the copy-paste program. The two instructions inside the highlighted boundary have the effect of executing the move string instruction for a number of times. Therefore, instead of using the loop instruction, we can prefix the move string instruction using the repeat prefix. The prefix instruction has the effect of copying items from the source block to the destination block. The standard practice nowadays is to write programs using high-level programming languages. As compared to low-level programming languages, high-level languages are easier to comprehend and less tedious to use. High-level programs are converted into machine code using a process called compiling. Generally, a single high-level program statement may compile into a number of machine instructions. Let's illustrate using the C statement Z equals X plus Y, where Z, X, and Y are memory locations that contain integers. Let's convert the statement into a suitable assembly program section. We can see that the corresponding machine code is made up of 3 instructions. The first instruction copies the contents of memory location X into the accumulator. The second instruction adds the contents of memory location Y to the contents of the accumulator. The third instruction stores the accumulator into memory location Z. Effectively, these 3 instructions carry out the operation depicted by the C statement. I recommend that you do these questions from chapter 5 before you proceed to the next section. Let's look at some steps that can be followed when developing programs. The first step is to understand the problem. You look at things like form of data involved. Is it integers? Is it floating point numbers? Is it characters, etc.? You also look at the necessary interface circuits that may be required. It is also important to understand the existing ways of solving the situation at hand. Step number 2 is to develop the algorithm. The algorithm may be in the form of a flowchart, or it can be a sequence of step-by-step statements. The third step is to write the program. This means basically converting the algorithm into a program using a suitable programming language. The fourth step is to assemble or compile the program. The resulting machine code is loaded into memory and run so as to test and debug the program. Testing and debugging may run for a number of iterations before a perfect solution is realized. I recommend that you do these questions from chapter 5 before you proceed to the next lecture.